Let's graph f of x equals negative x plus 2 cubed plus 4. First of all, notice that this is the base graph for this is going to be negative x cubed. Now you might think, no, it's positive x cubed, and it could be, but I would rather use the base as a negative x cubed. So all I have to do then is flip that one right 2 and up 4. It's a lot easier to do it that way. So your base graph, let me erase that stuff. If your base graph is negative x cubed, that's, instead of positive x cubed would be here, negative x cubed flips over the x-axis, so it's here. Alright, so there's your base graph. And remember, with a cubic, I'm starting here. This is my handle point, I like to call it. 0, 0 is my handle. That handle point's going to move left 2 and up 4. So that handle point's going to go 1, 2 to the left, and 1, 2, 3, 4 up. There's your point. I'm going to label it. It's negative 2, comma 4. That's your vertex, so to speak, even though it's technically not a vertex. For a cubic, it's not called a vertex. For a parabola, it is. A quadratic, but not for a cubic. Now, what does it do? Remember, what do I do when I move that point? What does a cubic function do now? Well, remember, the base doesn't look like this. It looks like this. It flipped. So it's going to go left 1 and up 1. And it's going to go right 1 and down 1 from that point. And then it's going to go left 2 and up 8 from that point. So it's going to be up there somewhere. Or right 2 and down 8. So what would that be here? So there's our graph. Let's graph it. That's your graph. And let's test these points. This is what I always do. So that point right there is negative 1, comma 3. That point right there is negative 3, comma 5. Let's test these points in my equation right there. So I'll do this in color. If I plug in negative 3 for x, negative 3, what's negative 3 plus 2?
Negative 1.
Negative 1 cubed is?
Negative 1.
Negative 1. And what's a negative? Negative 1.
Positive 1.
Positive 1. Plus 4 is?
5.
5. And that's how I know that I did it right. I plug in a couple test points. That's how I would suggest you do that problem. Let's try a different one. Let's try g of x equals negative 2, negative 2 absolute value of x plus 1 minus 3. Now I'm purposefully making this as complicated as I can think offhand because I want to show you how easy it can be if you really understand transformations. So here's what I'm going to do. First of all, what's the base graph here?
A V.
It's a V, right? And it's not only a regular V, it's what kind of V? Because of the negative here, it's what kind of V?
Upside down.
It's an upside down V because that flips it, right? And what does the 2 do to it?
Flips it. And I calculate.
No, it doesn't flip it. What does multiplying by a number do to it over 1? It stretches it out. Think about your regular V. If your regular V looked like this, which it does, something like this, if I multiplied 2, that's the absolute value of x. If I did 2 times the absolute value of x, it takes every point, instead of going over 1 up 1, it's over 1 up 2, over 2, instead of up 2, it's over 2 up 4, because your slope is 2, right? So it makes your graph steeper like that. All right, that's what that does. So let's think about. Let's just remember that as I graph this. So this right here moves it which way?
Left.
Left 1, and this moves it which way?
Down.
Down 3. So my V, which normally would have started at the origin, that middle point, that vertex, is actually left 1 and down 3. Alright, now watch how easy this is if I can understand that idea of that slope. When I go over 1, I would normally go down 1, right? But because of the slope is 2, I'm going over 1 and I'm going down 2. So there's your point right there. And when I go over 2, I would go how many down? Normally I would go down 2, but now the slope's 2, I go down 4. So there's my line, and then it's going to be symmetric to that. Over 1, or left 1, down 2, left 2, down 4. There's your graph. Let's test it. What's that point right there? Name it for me. 0, comma, -5.
-4, I think. Not sure.
I think it's -5, isn't it? 0,
Yeah, it's
-5. And so this right here is what? What's that point? -2, -5?
Yeah.
Let's test them. Plug it in. When I plug in -2, what's -2 plus 1?
-1.
-1. What's the absolute value of -1?
1.
Positive 1. What's 1 times -2?
Negative.
-2 minus 3?
-5.
-5. It's also good to do that for the sake of practicing mental math. Plug in 0. I'm testing this one now. Plug in 0. 0 plus 1 is?
1.
1. Absolute value of 1 is? 1.
-2, and then -5.
That works. Always test your points.